Hey guys, I have the notes written out here. I'm just going to kind of explain them. Um, Again, I already finished, but I'll explain. So, first of all, sketch a parabolic curve. So remember, parabolic curve is that U-shaped graph, and it's just noting the vertex is that point that kind of divides it into two equal halves, so left and right. Did my graph open up or down? Well, this one opens up, and obviously one could open down. Here it explains if the coefficient of x squared is positive, the parabola opens upward, and if a, the coefficient, is negative, the parabola opens downward. The vertex is the lowest point when it opens upward, or the highest point when it opens downward. So, you have your vertex here, vertex down here. Parabolas are symmetrical. The left and right side match exactly along what's called the axis of symmetry. The axis of symmetry would just be like a line going straight down the center of a parabola. So anyhow, you have in the first example here, example 2 that is, graph the parabola y equals x squared plus 4x plus 3. The first question, does the graph open upward or downward? Well, it has a positive x squared. A is 1, so it will definitely open upward, as you can see here. And then in order to graph this, you want to do a couple things. You want to use this little formula here, negative b over 2a, to get x. It is aka the x coordinate of the vertex. So here's the vertex, and you can get the x coordinate of that. So I was just talking about finding the x coordinate of the vertex, negative b over 2a. Use that formula to get the x coordinate of the vertex. So for this one, negative b is negative 4 over 2a, so over 2 times 1. So you see that here, negative 4 over 2 times 1. And it reduces all the way down to negative 2. Negative 2 is see, I'm making points over here. Negative 2 is the x coordinate of the vertex. If I plug it into the equation, I'll get the y coordinate. So I did that. I took the equation, plugged the negative 2 into it for x, right? Negative 2 squared plus 4 times negative 2. You see that work here. And then, simplify it all the way out and to get negative 1. So the vertex is negative 2, negative 1. Again, you use negative b over 2a to get the x coordinate of the vertex, and you plug it into the original equation to get the y coordinate. So vertex is negative 2, negative 1. From there, what you want to do is you should find things like the x-intercept and the y-intercept. The y-intercept is where x equals 0. So if you plug in a 0 for x, you can get the y-intercept, which was 3. So here's that. And then if you want the x-intercept, plug in a 0 for y. Plugging in a 0 for y, you can see here to get the y-intercept, or wait, sorry, I think I might have this labeled a little bit backwards, right? If I plug in a 0 for x, this should say y-intercept, and then if I plug in a 0 for y, I actually got the x-intercept. So anyhow, these are mislabeled, but that being said, the work is right? This work here is for the y-intercept, and down here for the x-intercept. And you can see I factored to solve this. Remember, if it equals 0, you can solve it by either factoring or quadratic formula. So it factors down to x plus 3 and x plus 1, because 1 times 3 is 3 and 1 plus 3 is 4. Solve both of these, right? Set them equal to 0, and you get x equals negative 3 and x equals negative 1. Or, yes, x equals negative 1. So anyhow, I think I copied it down wrong here, guys. This is x plus 3 and x plus 1, and this should be a plus here and a plus here, and when I solve it, it's negative 3 and negative 1. So anyhow, I have my vertex, my y-intercept, my two x-intercepts. So I graph my vertex here, negative 2, negative 1, and I graph my x-intercept here, and I graph my y-intercept, and then this other point here, I actually didn't plug in the negative. I believe that's a negative 4 there. I didn't plug it in because basically I know that a parabola is going to match on the right and left. So like these, here's the center, here's the vertex, and then these 2 points match up on the, the height. Let's say the height is both basically even. So when I go another space over and there's this point here, I know it needs to match when I go another space over to the other side. So I can kind of get this last point just by mirroring it from the middle where this one is, and then mirror it to the left side. And I got that point just by knowing that a parabola is symmetrical on both sides without having to like plug in. So there's that one. And you go to the next page. So the next page of the notes here. So this right here, guys, this problem is the same as the last one. First thing I did well, first of all, it's a positive x squared here, so it definitely will open upward for, again, positive 1x squared. After that, I use negative b over 2a to find the x coordinate of the vertex. So b is negative 6, a is 1, so negative b over 2a, this is the work here, negative 6 over 2 times 1, becomes 6 over 2, which is 3. Once I have that, I plug it back into this equation, and here's the work for that. Plug in that 3 and calculate to get y equals negative 1. So my vertex is 3, negative 1. Once I have my vertex, I plug in a 0 for x to get the y-intercept. You can see that work here. The y-intercept is 8, so 0, 8. Once I have that, I plug in a 0 for y to get the x-intercept, and you can see I did that here. I factored to solve, and then once I factor it, I come up with that my x-intercepts are 2 and 4, so 2, 0, and 4, 0. And then I graph all these points. 3, negative 1, you can see the vertex is there. The x-intercepts, 2, 0, and 4, 0, you can see those. The y-intercept, 0, 8, you can see that. And then this point over here, I just get this point by matching it up to this one. This point is like, I don't know, I think it's 3 spaces from the, what's called the axis of symmetry, the line that divides the parabola evenly in 2 halves. So again, once I see this point, I can kind of mirror it over on the right side to get that one. So I calculated 1, 2, 3, 4 points, and then this 5th point, I can just kind of mirror it from the one I have over here on the left. So quick note here, what we already looked over. To find a parabola's x-intercepts, you set y equals 0 and solve for x. To find a parabola's y-intercepts, you set x equals 0 and solve for y. And you can see all these problems I did the same thing. I find the x-intercepts, right, by setting y equal to 0 and solving, and I pretty much solved all of them by factoring, so you could see on all of them, like, the x-intercept, right, like it crosses the x-axis at negative 2 and 6, but you can write those as ordered pairs, negative 2, 0, and 6, 0. So I did the same thing on all of these, set y equal to 0 and solve by factoring. Definitely could solve with quadratic formula, that would also work. But either way, some of them I did have to factor out a negative 1, but even factoring out a negative 1, once I do that, I can factor what's left over. Same thing on this one, when I factor out a negative 1, I can then factor what's left over and still come to these answers for the x-intercepts. And then as I get to example 4, finding the y-intercept is easier, because I just have to plug in a 0 for x and solve for y, but as you can see, when you plug in a 0 for x, everything kind of goes away, and finding the y-intercept is a lot less work. So again, just plug in a 0 for x, solve for y, and you get your y-intercept. So there's those y-intercepts. And then this page here, guys, this page is just finding the vertex. So we've already done that. The first couple problems where we graphed, we found the vertex and the x-intercepts and y-intercepts. So right here, this is just easier because we only have to find the x-intercept. So again, you take your equation for your quadratic, for your parabola, and you use negative b over 2a to find the x coordinate of the vertex. So this one was negative 6, which is positive 6 over 2 times 1. So the x coordinate is 3, and then when I plug that 3 back into this equation, I can get the y coordinate, and you can see the work here, and I came up with 1. So the vertex is 3, 1. Did the same thing on this one, you guys. I used negative b over 2a to get 4. Once I get 4, I plug it back into the original equation, and I get 1 for y, so the vertex is 4, 1. On practice 5, it says make up a quadratic equation and find the vertex. I obviously just did that, but normally if it was in class I would ask you guys to do it, but since it's not, you can just still just use this as like one more example. And then I found the x and y intercepts on this equation that I made up. So that's about it. Hopefully this helps. See you in class.